Hello everyone. This particular video is for 12th standard students in Tamil Nadu, and the video is focused at the government syllabus, Tamil Nadu State Board syllabus in English medium, computer science. This is my effort to share the knowledge I have in all the units for the year 12 syllabus. One of the reasons I am sharing this video is that I do work in IT industry since last 25 years, and here I would like to share the knowledge in this particular subject so that can benefit the plus 2 or the year 12 students of Tamil Nadu. Towards the end of the video, I'll try to summarize in the local language Tamil as well. So this is the first video which is focused on Unit 1, and if you like the content of the video, please share with your friends as well as provide feedback so that I can further improve the video content in future series. Okay, let's move on to the topic. As you know, the particular this subject has got multiple units, like 5 units, and each of the units has multiple chapters. So here we are going to focus mainly on Unit 1, which is about problem solving techniques, but it contains 4 different chapters. The first chapter is about functions, second data abstraction, third scoping, and the fourth one is about algorithmic strategies. So let's go into each chapter first and see what's it about. So functions. So you would have studied about this in 11th standard already, but I'm going to talk about it briefly and then talk about the details of it in coming slides. Function is very important in a computer programming because without functions, sometimes you can't build a proper program. And when there is functions, obviously parameters and arguments play an important role in that. And all the functions are very much used in different types of computer programming today. So what's the function specifications? Function consists of multiple elements. First is I would call it as algorithm. So algorithm is nothing but it's it's a statement of any programming language. Um, Without an algorithm, you cannot execute a particular program. So meaning um, a subroutine, a function and algorithm go hand in hand. So what does that mean? If you see the summary in this particular slide, the 4 elements which make an algorithm. For example, I'm going to go from bottom to top. First is subroutines. Subroutines, they are the basic building blocks of a computer programs. They are nothing but, it's a small section of code to perform a particular task. For example, let's say you want to do an addition. You want to say 1 plus 2 is equal to 3. So you can program that or write small subroutines to achieve that outcome or the answer. So generally subroutines are called as functions actually, or functions are made of multiple subroutines. That's how you have to understand. And when you talk about any function, it always will have a set of code with inputs as well as outputs. What's that mean? Input such as variance, expressions are needed, including parameters are needed to produce a correct output. So when you're writing a computer program for 1 plus 2 equal to 3, it's one time task. But let's say you want to repeat the same addition many times with the different numbers. Let's say 2 plus 3, 4 plus 2. You don't want to write a program each time saying these numbers. Instead, you can pass parameters or variance to the particular function so that you can use a program repeatedly million times or 100 million times, whichever times you want. But the point is there is always an output, meaning there is an answer, which is in this case 1 plus 2 is equal to 3 is the answer. So that 3 is the output, but 1 and 2 are the inputs. Okay, we'll see more examples in coming slides about it. When you talk about an expression, the expressions are very simple because sometimes you can send a parameter in the form of an expression, and not just by sending a numbers, right? That's why it is called expression. So when a function can be repeatedly called multiple times itself, then it's called a recursive function. So it's kind of, whenever you build some kind of looping mechanism where you want to repeat something again and again and again, then that type of function is called as recursive function. So I'm repeating one more time. So subroutines, who are basic building blocks of computer programs, help to form a function, and functions perform well if you're passing variants and expressions as inputs so that they will produce concrete outputs. And if a function can be repeatedly used, or a function can call itself one more time, then it's called a recursive function. And the parameters are nothing but, again, they are variables in any function definitions, and the arguments or values passed to a functional definition. So these are values like, as I said, let's say a parameter can be a as a parameter, but the value of the parameter could be 22. So that's how they operate. So every parameter will have an arguments, and without an argument you cannot get a concrete output. So that's simple as function. Hope that's clear. So let's move on to the next one. It's a I've given some more examples. Obviously, I've used the OCaml programming language because that's quite commonly used in your books. This in the above example, you can very clearly say B is the parameter and the value passed to it is the argument. Now, the precondition of this function requires and the postcondition is returns. What does that mean is that the definition is introduced by the keyword called let, followed by the name of the function. Parameter with type, which is important mainly because it's useful for debugging errors on compilation. Normally all functions are static definitions and there is no dynamic function definition. It's good to practice an example to check whether we entered a number is even or odd. I'm pretty sure you can find this example in your book, but there are very simple function as well. You can also try in your computer lab. Okay. I'm moving on to the next topic, which is the interface versus implementation. So this is something interesting because these are fundamentals before you get into detailed programming knowledge. So what is a simple definition? Because you need to know the definition, because when you get one word, one mark or 2 marks questions, you exactly know what to answer. So it's important you memorize some of these definitions. At the same time, you understand them, right? That's what's critical. So interface is a set of action that an object can do. So you know already an object is normally it's an instance, it's created from any class, and a class declaration combines the external interface with an implementation of that interface. The what is that? Nothing but the code which carries out the behavior, the code which will give you the answer what it's supposed to do. For example, when I said 1 plus 2 is equal to 3, if you write a code to achieve that, that's the implementation part of it. Normally in Python, because a class is created by the keyword class, because more than one class is possible in a program. And a class template specifies the interfaces to enable an object to be created and operated properly. So in the example, you can see there, when I say a class drink, it's unique class. There could be another example, I can say class dress, for example, class food. So there are unique classes which helps to distinguish between different classes. An object's attribute and behavior is controlled by sending functions to the object as well. So as you see in the table, an interface just defines what an object can do, but won't actually do it. Um, so, so in this case, you can see the objects are multiple. Yeah, tea is an object, coffee is an object. It can be a juice, water, anything. Each has its price points, and the drink is the class which is made of different objects basically. Now, when you see the implementations outside, you can very clearly see, you start with the price setting as default value of 0, and then from the class T, you can derive many things. So now you have defined T as a class, and when you start, and sorry, as an object, and then for the object, there are different characteristics. So for example, you can be T dot color is equal to green, or T dot sweet equal to yes. So there are different values you can allocate for an object. Okay, so I repeat, the interface is a set of an action that an object can do, and a class declaration combines the external interface with an implementation of that interface, uh, which is nothing but a code that carries up that behavior. Hope that is clear. Next important topic is about the function type. So we talked briefly about function in a few slides ago, and there are uh, di different function types, and we're going to talk about what are pure functions means. So the pure functions are all those functions, they which will provide exact result when the same arguments are passed. For example, so we're going to do a squaring a variable y, and you return that answer as you can see written y multiplied by y, which is y squared. This is an example of a pure function because it will not give any different results for the same input. Advantage of it is mainly because if it's called several times with the same arguments, the compiler only needs to actually call the function once. Because the compiler remembers the first time it called, and since it's a consistent function and it's pure, compiler is smart to understand that to call once. For example, I've given a JavaScript example here where you can see that the update my name, it's a function. It doesn't worry about any external coder to complete its function. Instead, it just takes the values which is coming through the constant my names, and then it allocates the data. So whenever you're after find the length of it, it constantly gives the same value. So basically there is nothing changing here. Everything is consistent. Whatever values you will pass through my names, it will just take those values and constantly process it. Okay, so and hence pure functions are those functions which will provide exact result when the same arguments are passed. So that's important for you to remember. Okay, talking about impure functions. So now when a function depends on variables or another function which are outside of its definition block, then the function may not behave the same every time it's called. Meaning there is no constant behavior because the values may change from the variables or the functions outside of it. And hence such functions are called impure functions. So in summary, the variables used inside the function may cause side effects through the functions which are not passed with any arguments and hence called impure functions. So in this example, the value of y get changed inside the function definition, due to which the result is going to change. So you can see that y has got y plus x. Um, as values of x, it's also dependent not just on y value, it's also dependent on x value. So every time one of them can change, it's going to constantly, the net y values keep going to constantly change. Okay. So in Python, if you want to increment a variable, obviously this is just a tip, you can use plus equal to sign, or you can also reassign saying x is equal to x plus 1. So for example, if this is about incrementing a particular variable by 1. Another example is y is equal to y plus 1 as well. So let's say if you say give a value for an x equal to 0, and then you also perform x is equal to x plus 1 and print the x, it can go on a loop, right? Like you can, for this particular one, it could be 20 plus 1 equal to 21. But if you want, you can also build a recursive function as well and put it in a loop, and you can print infinitely, or you can also stop. Let's say you want to stop at less than 100. So there are many things you can do with this type of impure function concept. Most of the time, impure functions are used in general programming in our world. So it's something important to know and understand how to build such programs. I've given one more example from a JavaScript. The reason I give JavaScript is sometimes quite commonly used in IT industry, as well as it's easy to understand sometimes compared to Python. Anyway, hope this will help. So in this case, it's a function of update my name. Again, the new name you can see very clearly. The my names has been declared outside the function. Um, it's because it contains my names that mutates an external stage which gives update my name some side effects. So what does that mean? They're saying because it's declared outside the function, there is no control on the values of my names. If there could be any changes, it will immediately impact the behavior of the or the output of the function in this particular example, and hence it's called an impure function. Hope that is clear, and let's move on to the next table, which is important again from exam perspective. You may get questions on this. Okay, compare and contrast or distinguish between pure functions and impure functions, and you can find this in your book as well. This is just a summary table for revision. So as I said, on the pure function, the return value of the pure function solely depends on its arguments passed. They do not have any side effects. But impure function, it does not solely depend on its arguments passed, and the return value could change basically. Um, Second point is they do not modify the arguments which are passed to them. They're consistent. But in impure function, they may modify the arguments which are passed to them at any time. And third one, if you call the pure function with the same set of arguments, you will always get the same return values. In impure function, if you call the impure functions with same set of arguments, you might get the different return values. And the common ones are random. Some functions include random date. Date constantly changes. These are quite commonly used in the programming side in even Python as well. Cool. So I think before we go into chapter 2, the chapter 2 is an interesting one because it's also going to talk more about the abstracts of data structures and difference between concrete and abstract implementation, pairs, which is a very commonly used concept, as well as the structure in general. So what I recommend you to do is, before we see a next video on just focused on chapter 2, I'm going to pause here and stop. I'm keen to get your feedback on chapter 1 so that I can also launch another video on chapter 2, 3, and 4 of Unit 1 shortly. Until then, you all have a good day.